Hello, my name is Pierce Brown. I'm one of the math tutors here at the DLASC. Last time in my previous video, I went ahead and derived the integrating factor as I of x equal to e to the integral of p of x with respect to x. And now I'm going to work an example problem using this method. So write that off to the side. Our problem is going to be dy dx plus 2 over x, y equal to 5x squared, comma, x is going to be greater than 0. So previously when I derived integrating factor, we wanted to do a couple of things. First, we wanted to get the equation to be monic, y prime p of x y equal to q of x, and be in this form of y prime plus p of x y equals q of x. And that's what we have here. I'll go ahead and rewrite this dy dx as y prime 2 over x y equal to 5x squared. And now we need to find out what is our integrating factor. The integrating factor is going to be e to the power of this function right here. This is our p of x. So 2 over x dx. Using a quick substitution, we would let u, or rather pulling out this constant, you don't actually need to do a substitution. We'll have 2 of the natural log of the absolute value of x plus c. Now, a couple of things before we go on. First off, if you'll notice the plus c here, we're kind of choosing almost an arbitrary I of x here. So I'm just going to choose I of x when c is 0, because that makes my life a lot easier. And then also I'm going to bring over this 2 to the exponent of x using one of my log rules, giving me e to the natural log of x squared. Again, that c is going to be 0. And we can drop our absolute value sign because x squared is only ever greater than or equal to 0. It's never negative. So simplifying, we're left with x squared. Now I'm going to multiply my entire equation by the integrating factor. So y prime x squared plus 2x squared over x, y is equal to 5x to the 4th. Doing a little bit of simplification, we can see that this will cancel, meaning we have y prime x squared plus 2xy equal to 5x to the 4th. And now you can clearly see that this is a product rule. Here's our f prime, here's our g, plus here's our g prime, and here's our f. So this equation is going to be equal to taking the integral of both sides with respect to x, of course, is going to be equal to the derivative with respect to x of these two functions, y times x squared dx equal to the integral of 5x to the 4th dx. So you can kind of think as this step canceling. I didn't say that in the previous video because technically integrals and derivatives are not things that you can cancel out like that. But for this instance, it does work that way because we are integrating with respect to x. So what we're left with is what's inside the brackets here, equal to the integral of 5x to the 4th is going to be 5x to we add 1 to the power, so 5, and then divide by the new power. these will cancel. And then we have our arbitrary constant c. From here, to isolate y, we would divide everything by x squared. So y is going to be equal to x to the fifth plus c all over x squared. From here, we can rewrite this as x to the fifth over x squared plus c times x to the negative 2. That way we can see that these are going to cancel out, meaning that y is going to be equal to x to the third plus c to the x to the minus 2. And that's our general solution for this equation. If you were given some initial value, these are going to come in the form of y of, let's say, 1 is equal to 4. You would be able to evaluate this equation simply by 4 is equal to x to the third plus c 1 to the negative 2. And this x, of course, is going to be a 1, meaning that 4 is equal to 4 minus 1 is going to be equal to 1/2 c. So our c value is going to equal to, multiply both sides by 2. This is a 3, 6. And our general solution was the x cubed plus c x to the negative 2. But our specific solution, given this initial condition, is y is equal to x to the third plus 6 times x to the negative 2.